My name is Edmo Campos from Brazil, and I'm here representing a group of scientists from different institutions around the world, some of them in this audience today. In this presentation, I will be showing you results we published recently in GRL showing or confirming that the temperature in the South Atlantic, or the Antarctic Bottom Water in the South Atlantic, is not only increasing, but possibly increasing with an accelerated rate in the past few decades. Let's start with this. We know that the ocean, by means of this global thermohaline circulation, plays a very important role in the climate system. We also know that a slight change in temperature and salinity in the ocean may result in change in the thermohaline circulation and eventually and consequently change in the climate system itself. In the Atlantic Ocean, the thermohaline circulation can be represented by this Atlantic Meridian Overturning Circulation, or AMOC. The AMOC is actually composed by two cells. The upper cell, that is the more known component, formed by warmer waters flowing to the South Atlantic, to the North Atlantic, and eventually releasing heat to the atmosphere, sinking and then flowing back to the South Atlantic. But there is also this lower cell. The lower cell is formed by water sunk around Antarctica, flows to the north, and eventually return south together with the deeper branch of the upper cell. Important component of this lower branch is, or the lower cell of the AMOC, is that properties acquired near the surface are usually carried for long distance as part of the AABW flow. It is also important to point out that the latitude 34.5 degrees south is a very important region to monitor the Atlantic Meridian Overturning Circulation. Motivated by this importance of the 34.5 degrees south, or actually the importance of the South Atlantic in this meridian overturning circulation, in the beginning of the century, a group of scientists from different countries decided to start a program to monitor the AMOC in the southern components, or the southern regions of the Atlantic. And this program is started by around 2007, and it's named the SAMOC, or the South Atlantic Meridian Overturning Circulation Program. And within this program, a very important component is this line of instruments that extend from South America to South Africa. It's normally referred as the SAMOC Basin Wide Array, or SAMBA, and it's maintained by a consortium of institutions from at least 6 or 8 countries in Americas and Europe and Africa. In Brazil, the Brazilian component of SAMOC is funded by the São Paulo State Funding Agency, FAPESP, and is composed by regular hydrographic cruises in the western part of the SAMBA line, and also includes the mooring of instruments on the West Samba, and also a moored platform near the bottom in the Vema Channel, which is a deep channel between the Santos Plateau and the Rio Grande Rise, connecting the Argentine Basin and the Brazil Basin. It is through the Vema Channel that most of the Antarctic bottom water that flows from the Argentine Basin to the Brazil Basin goes through in its way to the north. Data collected by SAMOC have been used in different publications in the recent years. For instance, this one published by Marion Cassalet and a team of colleagues from different institutions have found that both the upper and the lower cells of the AMOC in the South Atlantic present high variabilities in periods ranging from a few days to weeks, in addition to the low frequency variabilities normally expected. The first 10-year data set collected along Samba was used in a publication in GRL in 2020 with an important result showing that the temperature of the abyssal waters in the South Atlantic has been increasing, or at least increased in the past decade, the decade that covered by the SAMOC observations. As seen in this slide, the water that is formed around Antarctica, and in particular in the Weather Sea, forms a bottom current that enters into the Argentine Basin and eventually crosses the Vema Channel into the Brazil Basin in the South Atlantic. This Vema Channel is, for this reason, Vema Channel is a very important region to monitor. And in January of 2019, a platform composed by a current meter and a microcat, among other sensors, was installed, was moored in the Vema Channel at about 50 meters above the seafloor. The data from the Vema Channel collected by SAMBAR was analyzed in combination with data from other current meters, other moorings, historical data in the Vema Channel, and also CTD data collected by hydrographic cruises in the region. And the results show clearly that from the 1980s to the end of the 2020, there was an increase of 0.059 degrees Celsius in potential temperature from January 91 to August 2020. And most importantly, in fact, it looks like that the rate of increase of temperature around 2005 or 2005 and 2007, the rate of increase jumped from about 0.0016 degrees Celsius per year to 0.0026 degrees Celsius per year. So a considerable increase in the temperature rate, suggesting that the temperature is not only increasing, but it's increasing with an increasing rate. So, in summary, the Antarctic bottom water in the Vema Channel is warming up. There was an increase of about